Hi friends. So up until now when we've seen an equation in standard form, we've changed it into another form. We've changed it into vertex form to graph it, or we've changed it into factored form to find the roots and graph it. But of course, there is a method for graphing straight from standard form. It just requires remembering a little bit more information. So hopefully this video will help you learn, and you'll probably need to reflect and remember these steps more carefully than in other forms. So the first thing that we should always do if we see an equation in standard form is we should always start by finding out what the y-intercept is. So of course, if I know that the y-intercept is where x is equal to 0, so plugging in 0 for x, the first two terms are just going to cancel out. And so the y-intercept will always be this c value, remembering, of course, that the standard form is in the form ax squared plus bx plus c. So the y-intercept is the point 0c, or in this case, 0, 1. So I can come over to my graph and just plot the y-intercept as the first point that I'm going to graph. Then I'm going to need to apply this nice little rule that I learned in class. This is the one that we derived from our work today. So we know that x is equal to negative b over 2a. And again, remembering that this is ax squared plus bx plus c, a here is equal to negative 3, and b is equal to negative 6. So because the axis of symmetry line is found here, basically where the radical part of the quadratic formula is 0, I'm just going to be able to plug in these values. So x is equal to negative b is negative 6. And a is equal to negative 3, so that's over 2 times negative 3. So that gives me the value positive 6 over negative 6, or negative 1. So my axis of symmetry is along the vertical line x equals negative 1. So if we were to graph that, we would just take this vertical line and put it right along where x is equal to negative 1. Could even label that there. That's my negative 1 value there. Okay. Now, of course, I've got one point and I've got an axis of symmetry, and I have a general idea of what my parabola is going to look like. I know it's reflected, so I know it's going to open downwards. I know it's has a stretch value, or a vertical dilation of 3, so it's going to be pretty steep. But I'd like to know exactly where that other point is. So I'm going to take this x value for the axis of symmetry, and I'm going to plug it back into the formula, or into the original equation. So I'm going to basically evaluate this function for when x is equal to negative 1. So that's negative 3 times negative 1 squared minus 6 times negative 1 plus 1. And so that's going to give me negative 3 times 1, which is negative 3, plus 6 plus 1, or 4. So the point for the vertex is at the point negative 1, comma 4. So along this axis, negative 1, 1, 2, 3, 4, right there is my vertex. Now I'm going to need to have a couple of other points on my table, right? My vertex will be sort of here in the middle, negative 1, 4. I'm going to need a point to the right and a point to the left. But I already have a point here. I already have the y-intercept. So I know that at 0, which is one sort of beyond -1, I know that my point is 0, 1, which means that if one to the right has a vertical coordinate of 1, then one to the left of my axis of symmetry will also have a vertical coordinate of 1. So that's the point -2, 1. And so there I've got 3 points. And I could, of course, plug in some more points if I wanted to, but now I have a pretty good idea of the general shape of this parabola. And so I can come in and draw it just like that. So that's an example for what to do when you have an equation in standard form that is, for various reasons, trickier to turn into vertex form or factored form. There are a few example problems, and I look forward to your questions in class. Thanks.